Ladies and gentlemen, welcome to this. Thank you for participating in this third edition of the World Power to X Summit. Please allow me to introduce myself. I am El Mehdi Rahiwi, the Communication and Partnership Advisor at Industrie du Maroc. Well, the green hydrogen and carbon neutrality topics have become global consensus. Solar energy can play a key role into this direction, especially when more solutions are combined so to increase the load factor, face the intermittency, and the electrical grid challenges. With more than 30 years of experience in the power electronics field and more than 10 years in the solar industry, Huawei, our official partner, has contributed and still contributing into this energy has contributed and still contributing into this energy transition by providing smart, innovative, safe, and reliable products and solutions. In this session, Mr. Ahmed Rouizem, the Global Key Account Solution Director from France, will present the Huawei Smart PV products and solutions for utility scale and emphasize how Huawei can be a key player for green hydrogen production. Mr. Ahmed Rouizem, please.
Thank you very much. So, hello everyone. First of all, thank you for attending this session. It's a real pleasure for me to be here today and to give this presentation to show how Huawei actually can be a key player into the energy transition, and also show our vision regarding the digital and the solar power technology. Can you please switch to the next slide? Thank you. We all know that now the hydrogen is a market with huge potential. The global demand would increase and would be multiplied by 6 between 2020 and 2050. And now actually this market presents opportunities to many countries, including Morocco, for both internal use and international export. Green hydrogen, it's become now a catalyst toward the carbon neutrality objectives. These objectives actually are adopted in many countries. Now, in Europe, we talk about carbon neutral by 2050. In China, we talk about carbon neutral by 2060. In Japan, we talk about carbon neutral by 2050. And actually, this transition toward the carbon neutrality is accelerated by other factors. For example, the security of energy. So when we saw what happened actually with the price of gas in the last months, in the last years, we talk about, the Repower Euro program where 288 billion will be invested to between, 20 to 30 years to be much more independent from the gas. There is another also factor which accelerates this transition, which is, the economical value of renewables. So now, when you see actually the electricity prices compared to years ago, the prices of electricity were multiplied by 4, 3, even 5 times. And now the LCOE, as you can see, the LCOS, and also in some scenarios, the LCOH has been more competitive. So, okay, Huawei has contributed many years and 30 years actually into the energy transition. And by offering a complete package of solutions, this is what we will actually present in this session. And later on, my colleague Martin will present the BSS part. My presentation will focus more on the smart PV. And the topic here to produce, especially green hydrogen from renewables, is key, but this presents some challenges. So challenges, as you can see, I don't know if you can see here, but from challenges, you can see, for example, more renewables penetration will bring some challenges related to grid stability, voltage variation, like frequency variation, grid stability. And to overcome these challenges, I wanted through this slide to show our strategy, how we can support toward this energy transition by providing renewable products, smart products, and to overcome actually these challenges. So in this slide, you will see what we call the one-stop solution, Smart PV one-stop solution. We call it one-stop solution because you will have the same interface on all the project phases, from the design to the contractual discussion, to the tests in the factory, to the delivery, to the construction, and also for the operation of your PV projects. This one-stop solution is formed by two key components: the solar inverter, string concept, it is important to mention, and our transformer station with a common platform for the monitoring. So this solution, as you can see, to do it, we work mainly on three aspects. Firstly, the integration between the power electronics and the technology, digital technology integration. We work also on the combination of the PV with the BSS, as we'll explain later on in another session. And we work on a key parameter, which is the combination and the management integration between the byte and the watt. So it means managing the energy flow through the information flow. This is important. So Huawei did the choice to propose only smart string because at the beginning we assessed to go with also central solution, but we decided to keep and focus only on string concept. Why? Firstly, with the string concept, you will win on the availability. The product is designed, as you can see, with less vulnerable elements. What are the vulnerable elements? Firstly, as you can see, the inverter is with multi-MPPT concept. It helps to increase your production compared to a centralized solution. Secondly, we try to eliminate the fuses. So no DC fuses on the inverter. And you know DC fuses, it's CapEx, is OpEx, is energy losses when there is a problem with the fuses. We deleted all the screens. We don't have screens because you have the possibility to communicate with the inverter through the mobile phone application. And we integrated for the communication what we call the IMBUS, is the PLC communication, it's power line communication. And we take advantage from the EC cables used to evacuate the energy and the power produced by the inverter to communicate with the inverters. This IMBUS technology is 10 times much more faster than RS485. And this is key, especially for the reactivity. Some grid operators now, they ask for a short response time to the active and the reactive power. So with this technology, and thanks to our expertise from the telecom business, because the chipsets included within the inverter and the chipset included in our communication device helps to achieve this high response time. So another topic is we work within Huawei in the R&D, and you can check we invest between 20 to 25% of our annual turnover into the R&D. So our product is one of the lowest density kilogram per meter cube. So it's small, it helps to reduce the transport cost, the installation cost, and the OpEx cost for the replacements. Another aspect which is important, and this is also thanks to our experience from the telecom business, from the site, the availability of the equipment for the telecom business, is the product is designed with IP66 protection and C5M for anti-corrosion protection. So we can install the product in the harsh environments up to 4,000 meter altitude, and we can install it also close to the sea, up to 500 meters. So this is on the inverter side, and then it comes to the transformer station, which is actually a standard product, three powers, 3 megawatts, 6 megawatts, and 9 megawatt now on 20 feet container. This is important to mention because you will help to reduce actually the foundation cost, the transport cost. The solution is tested in the factory. Now it's almost pre-assembled. So we will deliver the solution combined in cabled between LV, transformer, and EV in the RMU station. Another aspect actually, which is also important, it's about the design, actually the heat design. We do a huge job actually on this because our product is designed to support up to 60-degree ambient temperature. And yeah. So beyond actually the hardware, as you can see it, when we design our product, because we take into consideration several parameters, we do a lot of sensitive analysis to decide the product range, the features we have to implement, but we pay a lot of importance to two key parameters, as you can see. First one is the safety of the equipment, and secondly, the reliability of the product. because we are here to accompany our customers for the long term, and we are not here just to do a project in 1 or 2 years. So safety is important. So as you can see on the DC side, and this is also based on my experience before joining Huawei, as I had several PV plants, more than 18 PV plants to manage on the operation and maintenance costs. The DC fault is a real threat to the PV plant. We cannot say that we can make the construction of PV plant without DC faults and arc fault on the DC side. So what we did on the inverter is we installed what we call the SSLD solution. It's a smart DC switch installed directly into the inverter, so which help to protect the inverter itself and the PV system against three kinds of faults. First one, the short circuit on the DC side. Secondly, the reverse of the polarity, which can happen during the installation. So I let you imagine with central solution with DC boxes, the technician switch PV plus with the PV minus, the risk of arc fault behind, and the risk of fire on the PV system and eventually the PV plants. The third point with this smart DC switch is we protect against the backfeed, because sometimes you can do your design, but you may have what we call the backfeed current. So thanks to the voltage in the current sensors with high precision we have on our inverter on each input, which help to follow precisely the current in the voltage sense on each input, and we can, in few milliseconds, separate the DC side from the AC side. Another parameter is based also on our experience. We found that there is a lot of problems with the DC connectors. When you plug, sometimes, you know, for central solution, you have to do, well, some measurements on string. You have to disconnect the string to make the IV curve and some management. The DC connectors are not designed to be disconnected for several times. So the preventive maintenance is usually designed 2 times per year. So I let you imagine in 5 years how many times you need to disconnect this DC switch and this DC connector. So what we did is we implemented temperature sensors on this, on the PCB connected to the DC connectors, and we will monitor the temperature. So in case of fault, especially for example, the arc risk on the DC connector, we will disconnect the inverter. In addition to this, for the safety of people, so we talk about the insulation monitoring on the MPPTs. So according to the IEC, the norm, the 62109 part 2, designed normally to, well, for the safety aspect for the solar inverters, the insulation monitoring is required, is mandatory at each start of the inverter. But for central solution, you will see many strings connected to the central inverter. When there is an insulation fault, it's complicated to locate the fault on the field. So that's, we integrated this, and we will be able actually to monitor the insulation on each MPPT, and we will let customer to know exactly which number of MPPTs are concerned by the insulation fault. So this reduces actually the energy losses, will reduce the fault location, so it's time, and also for string inverters. And I had the case also in the past, so you need to stop the whole block. You have to look actually for the fault on the DC cables, which are underground. So with the string concept, the DC cables actually just are behind the PV module, so it's easy to locate the fault and correct it quickly. So within Huawei, we don't only work on the hardware. We try to bring added value on other aspects, especially on the software. So we developed for solar industry 2 case solutions. The first one, we call it the smart IV curve diagnosis. This solution is based on the field measurements of the IV curve of each string on each input. We combine this with artificial intelligence and data mining to identify up to 14 faults on the string. So all what is related to voltage fault, current fault, PID, shedding, all these kind of faults. The solution was tested and certified by TUV, okay, with lab tests and also on-site tests. In addition to this, we developed what we call the SDS, the smart DC system. So, you know, with the traditional solution of the trackers, all the tracker tables will adopt the same angle, the same position to follow the sun. This is the astronomical algorithm. Now, with this SDS, and thanks to the string inverters, we have the visibility on each string, in each set of tables, or each table even. So with the development of the PV module technology, you know, especially bifacial technologies with different albedos on the side, different degradation for on 20, 25 years. Now we are even talking about business plans of 30, 35 even. So the degradation of the PV modules will not be the same. So behind the mismatch, will impact the generation. So with this multi-MPPT concept, we are able to expect with artificial intelligence to give the best angle to each table or set of tables to maximize the generation. So based on the test we did, we expect a higher yield due to this solution, which is more than 1%. So the other thing you have to mention here is this solution actually is just software solution. Once you have our inverters, smart logger, you don't need to add any additional hardware on site. It's a license to buy. You can buy it for 1 year, renew it, stop it, it's up to you. Here it's to show you actually the evolution of the string concepts, because in some regions we still see the central inverters as the mainstream, which is not actually the case in other countries, in other regions. So the story started since 2014, where a lab in Germany actually compared our string inverter with other products, and they confirmed the added value on the yield, on the production. At the same time, we have several discussions, and we had several tests with other customers to test string inverter with central inverter on the same blocks, same configuration of tables, same sizing, and the customer confirmed the higher yield for string inverters. It's important. Then later on, it comes the decline, of the subsidy of solar. It comes the grid parity, and customers start to look more and more to more solutions help them to optimize the ROI. And that's why they turned to Huawei solution, because the solution was reliable, more availability, more than 99.5% availability, higher yield, as I mentioned before. And now we can see that the trend moves from 25% market share for string to more than 80% right now. And this can be checked. You just need to come back to the last report from Wood Mackenzie 2022, and you will see that Huawei is #1 worldwide using string concepts. We have more than 44% market share in Europe. In some countries with some big customers, we have 100% market share. They fully trust Huawei. They fully trust the added value on the safety, on the reliability, because, well, it depends on the customers. Some customers, they are more oriented price, CapEx. But some others, they will look to the safety, to the security, to the innovation you have in your product. And this is actually put us as one of the layer actually of the renewable solar inverters. So at this stage, we are really proud of what we did. So you can see when we contributed into the energy transition, we provide more than 300 gigawatts of smart PV inverters worldwide. This is the equivalent of, as you can see, of 770 million kilowatt hour of green electricity production and around 355 million tons carbon emission reduction, 485 million equivalent tree planted. So yeah, we are really engaged and committed to providing a high quality to our customers, safe and reliable products, and to contribute us to have a better future for our generation. So thank you very much.
Thank you so much, Mr. Reason, for the information, the valuable information you have just provided. Now, ladies and gentlemen, allow me to introduce our chairman, Mr. Drisi.
Hello, everybody. I will call the experts that will be with us today, Mr. Amin and Ms. Khadija. Two other experts are joining us online. Ladies and gentlemen, dear experts, welcome to this session First of all, and before starting this session, I want to add my voice to the one that preceded me and present my sincere condolences to all the families that have been affected by the earthquake of September 8th. Sessions today concern the comparison and harnessing of the potential of green technologies for the production of green hydrogen. Renewable energies are essential for the production of hydrogen as they offer a sustainable and environmentally friendly energy source. Various renewable energy sources have emerged as key players in this context. Exploring and comparing these renewable sources for hydrogen production provides valuable information regarding their feasibility, efficiency, and scalability. By utilizing renewable energies in hydrogen production, we can facilitate their integration into our energy system, decrease greenhouse gas emissions, improve energy storage capabilities, and contribute to the establishment of a more sustainable and resilient energy infrastructure. In this session, our goal is to analyze and compare the potential of three specific renewable sources: solar PV, CSP, and wind power. We will delve into the technical aspects, sustainable considerations, potential scalability, commercial viability, and limitations of each technology for large-scale hydrogen production. By exploring these aspects, we aim to gain a deeper understanding of their respective roles in promoting the adoption of green hydrogen as a sustainable alternative to hydrogen derived from fossil fuels. Before giving the floor to our experts, it's important to emphasize, can I have a mic? It's important to emphasize that the cost of energy is the main cost driver for the competitiveness of green hydrogen production, and it represents up to 70% of the green hydrogen cost production. As we can see in the figure above, during this last decade, we had a remarkable cost reduction in the green energy sources, especially solar PV, with almost 90% of drop in cost, and wind and onshore wind and CSP with near to 70% of decreasing of cost, which is very encouraging in order to reach the objective of green hydrogen reaching cost parity with fossil-derived hydrogen in the future. Additionally, and in order to optimize the production of green hydrogen, the electrolyzer need a stable feed-in from the green energies. So those are the two key factors for the green hydrogen cost effectiveness: stable feed-in and low LCOE. So the question is, what is the best renewable energy source for the production of a cost-effective green hydrogen? To respond to this question, we'll have a look on the pros and cons of each technology. So as shown in the slide before, the wind and PV have the lowest LCOE, but face some problems regarding intermittency and unpredictability for wind. On the other side, wind has a good capacity factor as it can produce after sunset, while for PV, the capacity factor is lower than 20%, as we can see in the curves on the right. It's important to mention that those curves are related to it's a global weighted average capacity factor and depend on the installation that has been installed during this last decade, because the capacity factor is influenced by the irradiation for the solar technology and by the wind speed for the wind technology. Regarding the CSP, the main barrier is the highest LCOE in comparison with the other technologies, but has a high capacity factor of between 40 and 50% depending on the technology of CSP, whether it's parabolic trough or tower. but those numbers can be upper than that, as it was the case in the Chile's Atacama Desert with a TES system with 17.5 hours that allow the plant to reach 80% of capacity factor as it can produce by night, but also with the CSP flexibility produce during the day when we have cloudy days or when the DNI is low. So based on the above, to respond to the question of the cost effectiveness or the best solution for the cost effectiveness, we can see that the solution is not to have a single technology, but the idea is to have a synergy between technologies or add a storage solution in order to take advantage from each technology with the aim of reducing the LCOE and having a higher capacity factor. So after this introduction, I will give the floor to our experts, starting by the first presentation regarding how can PV and wind hybridization help to optimize green hydrogen production. Thank you for joining me in welcoming our expert, Ms. Khadija Barada, who is currently Senior Business Development Manager at TAQA Morocco.
Hello, everyone. I am happy to talk today and participate to this panel. So I'm Khadija Barada. I'm from TAQA Morocco, and today I would like to share with you my thoughts regarding the renewable sources for hydrogen production. So, okay, thank you. So I will start first by a small brief presentation about TAQA and TAQA Morocco, and then go to share some ideas regarding the PV and wind for optimization of green hydrogen production. So, okay. So TAQA is today a global leading integrated utility, and TAQA is our main shareholder for TAQA Morocco. TAQA is operating in 3 main business lines, which are the generation of water and power, the distribution for also electricity and water, and also in oil and gas. TAQA have a strong financial performance and really predictable cash flows with a revenue of $13.6 billion for the last year, and also a very good EBITDA of $5.7 billion. So we have today, as an installed capacity, about 30, or I think 29.9, so yeah, to 29.9 gigawatts installed all over the world, with a share of renewables of almost 37% of wind, solar, and also geothermal. We are also today accelerating toward the low carbon energy with an objective to reduce the emissions by 25% by 2030. And also have a good participation and also a new installed capacities in renewable energies. So one of the case strengths of TAQA today is that is one of the largest listed companies in the EMEA region, and have a strong track record in even energy production and also for water desalination. So TAQA Morocco is present in Morocco from 25 years ago with an excellence in the industrial operation through our main asset, which is the George Philosopher power plant, which is a thermal power plant of 2,056 megawatts installed, which represents 19% of the installed capacity in Morocco and participates to 38% of the energy demand of the country. So we have reached a really availability rates that are very good. For the last year, we had 93.9% as an availability rate, and we have a strong track record in development of utility scale power plants, and also in the financial and structuring of utility scale projects. So our objective by 2030 is to have an additional installed capacity of 1,000 megawatts in order to achieve a combined low carbon installed capacity of 3,800 megawatts, and to reduce also our emissions by 25%. So for this purpose, we are developing several wind and solar projects all over the country. We have a wind project of 100 megawatts in the north region of Morocco, as well as 2 other projects in the south region with almost 300 megawatts. And also we have 2 solar PV projects in the center region, and we are looking for opportunities in the green hydrogen. So let's today talk about how can PV and wind participate and have a role in optimization of the green hydrogen production. So the first thing is, what is the importance of those technologies, or in general of renewable energy in the optimization of green hydrogen production? So I think today everyone knows that the largest, or maybe one of the largest impacts in the final cost of hydrogen are from electricity, and thus optimization of the LCOE or of renewable energy have a direct impact of the optimization of the hydrogen and of the levelized cost of hydrogen. That's why it is important to understand what are the requirements in order to optimize this renewable production. And for that, we need to know what, to understand what are the needs of the electrolyzer, or from the electrolyzer side. And if we see from this side, we look and we find that we need a green energy which is reliable, stable, and at the lowest cost. So let's start by this reliability. So we know today that we need an energy for the utility scale projects. We need an energy which is reliable, on which we can rely on day to day and season to season, and an energy that have these comfortable aspects for the developers. And if we see, for example, and have a zoom on the behavior of each technology, for example, the graph in the left of the slide, we see the monthly capacity factor of wind energy all over the year for 2 of our sites in different regions in Morocco. And we see how the behavior of wind energy really vary and differ from month to month. And even we have a gap of 50% from a season to season for one of our best wind sites. So this 50 impact gap between season to season is really impactful in the sizing and in the design of the green hydrogen production, and thus having a large impact in the LCOH. So in the other hand, we have solar behavior of PV 2 sites, the 2 same sites, where we have really stable, or let's say slight variation season to season. So I think the biggest gap is not exceeding 10%. So the stability that today solar energy is offering is really advantage if we have the possibility to have these hybrid sites in order to reduce the gap from season to season. So this is what we call the seasonal the seasonal synergy between both technologies, and the hybridization really helps to maximize the capacity factor of green hydrogen installation. And one important thing is that this hybridization is really site specific, because, for example, the result we could have here in Morocco will not be the same as in another region, or even in Morocco, the hybridization in one site would not the same as the hybridization in another site. So it's not like an absolute idea. Okay, we should do hybridization in all hydrogen productions installations, but this is really impacting parameters if we would like to optimize our installation. And in Morocco, we have this really advantage of having several sites with hybrid potential, not only having sites with good wind potential or another sites with good solar potentials, but we have this combination in the same site and in really large areas. And that is one of the main advantages of Morocco that makes Morocco one of the most competitive countries in terms of green hydrogen in the world. So also regarding the reliability, one impactful aspect is the predictability. So we know today that we could say that solar energy is more predictable than wind energy, and this combination give more insurance to the developers to have a reliable energy in the input of the electrolyzer. Sorry. So let's move to a third aspect, which is the stability. And the stability is also one really important parameter to take into consideration for the electrolyzers. So here in this graph, in the left side of my slide, we have compared for 3 of TAQA Morocco sites. We have compared the behavior of adding gradually PV installation into wind installation in order to see the impact of the shutdowns of the electrolyzer. And when we say shutdowns of the electrolyzers, that means that we have stress on our electrolyzer, we have maybe operational constraints, and that's having an impact in the final cost. So we see that when we move from when moving from the 100% wind scenario to the first hybrid scenario of 90% wind scenario, we see that we reduce the shutdowns, the number of shutdowns of the electrolyzer. And this is a really important thing, because when we reduce the number of shutdowns, you are also reducing the need for the solar capacity. So you are reducing the need for additional investments and additional stress into your system. And this is one really important aspect for reducing the final LCOH. So we find that today the hybridization allows for enhancing the stability and the reliability of electricity into the electrolyzer. Also, we could optimize our capacity factor for the electrolyzer, and also reducing the levelized cost of energy, and thus reducing the LCOH. So maybe for more clarification about this last sentence, so we have here one LCOH breakdown of one of our projects. So, and we see that only for the LCOH, the impact of electricity is like 66% of the final cost of hydrogen. So doing this optimization exercise is not a negligible thing to have in designing the project. And the impact of this hybridization could even reduce the LCOH 5 to 10% only by hybridization. So my last slide will be about integration into the grid. So maybe we will ask the question, okay, why we will have all those constraints to deal with if we could have the grid as a backup, and then have all this reliability of the grid, the stability of the signal into the grid. But one important thing to take into consideration that, okay, we will have all these comforts of the grid, but pay attention to the certification of your molecule that will be produced by the installation. And today, with evolving regulations and all the discussion about certification of the final products, maybe it will be more constraints on having the grid as a backup. And also, once you are connected to the grid, you have all the wheeling charges that are added to your cost of electricity, and that's an impact of the competitiveness of the hydrogen produced. In the other hand, having off-grid green hydrogen installations have, of course, some constraints, like the operational constraint that we have from the technical side, and also the storage capacity maybe that shall be added in order to meet the requirements of stability. But on the other hand, we are, let's say, safe that our green molecule will really be green one, and also we don't have those added wheeling charges. But once again, there is no one right answer for all green hydrogen projects. This reflection shall be done for every project, and it shall be project specific, depending on the final market, the target clients that we are targeted by our installations and their requirements. And maybe we could have another solution if we have another targets of markets. So that's all from my side. Thank you for your attention.
Thank you, Khadija. Now let's move to the next presentation regarding innovative approaches enabling scale and cost reduction with Mr. Amin Barada Sunni, who leads global strategic business development and marketing activities at Terabyte Energy.
Thank you, everyone. Can you hear me okay? So my name is Amin Barada, also Barada. We ran out of last names in Morocco a couple decades ago. So I'm a co-founder of Terabase, and I lead our strategic business development activities. So I'll cover today some of the innovative space that we've been exploring around reducing cost of solar. So as Khadija mentioned, and also Barry mentioned, solar is one of the lowest LCOEs that could be applied to green hydrogen. It can be better served when hybridized with wind as well. But our belief as a company is that we can further reduce the cost of solar. And so we'll discuss how we can do that. So I'd like to first start by introducing Terabase. We're a relatively new name in the industry, but we come from more established companies, so we'll explain that in a bit. So, but Terabase is focused on building an interconnected digital and automation platform to reduce the cost of solar and reduce and accelerate or increase the scalability of solar. Our view is that to reach decarbonization targets, we will need to build multiple hundreds of gigawatts of solar capacity, even terawatts of solar capacity. So we believe that scale and solutions for scale are important. So Terabase, we started the company in 2019, essentially an offshoot of the SunPower utility scale business. SunPower was an established company in the US, a leader in utility scale business. We are 5 years old. We've raised about $70 million to date. One of our leading investors is named as Breakthrough Energy. We're proud to have as part of our investors. We've made a couple acquisitions from another well-known US company called First Solar. And so we acquired their predictive tools called Plant Predict, and also their SCADA and power plant team, which is focused on grid integration and hybridization. And you'll hear more about that in our next session. We're about 100 employees, and then we provide integrated solutions. And now we are ramping up our production facilities for our automation line, and we'll explain in a little bit what that is. So in a nutshell, what we do as a company to explore cost reduction space and innovation space is basically bringing digital solutions and automation solutions to the field of solar PV primarily, and then also explore hybridization solutions to integrate that with wind, storage, and apply it to green hydrogen. So in the development stage, we have a set of tools that enable developers to basically accelerate development stage, reduce the cost, and then use essentially more productive ways of delivering on their development process. Saves a lot of money upfront in a risky phase of the project, which is essentially project development. And when the project is ready for construction, we basically offer a set of tools that enable us to monitor the construction of the site and smooth or accelerate the way a owner and an APC can communicate with respect to how a project is being built. And then on the operation phase, we have a set of hardware and controls that are able of implementing hybridization between PV, solar, battery, applied to green hydrogen primarily as our tool. And then finally, in the bottom of the slide, you will see our construction automation. And what that is really a assembly line that we send to all large sites for solar PV, and then we automate the way photovoltaic panels and trackers are being put together in the mechanical assembly, then automate some of the electrical steps as well. The goal is to build faster with a lower cost, essentially. So our view is that to reduce the cost of solar or the cost of green hydrogen, we need a multi-pronged approach, essentially an ecosystem approach. So our view is that a low-cost ecosystem needs to be put in place that combines digitization, automation, and then also co-localization. And a few ingredients need to be here to make this happen. We believe scale is one of the key ingredients. So multiple gigawatts, large projects will enable a drive this new approach. We believe digitalization is part of it. As I covered, some of our tools enable more productivity, enable just new ways of implementing the processes of building solar. Field automation, and then in the upper left corner, hybridization, which was talked about by Khadija and also will be talked about later by my colleague from Terabase, which enables a better utilization of expensive CapEx, such as the electrolyzer, but also get more production out of the site. We have a few tools to share with you there. But importantly, we will also believe that there needs to be a co-localization and a policy for building factories that make solar plants next to solar sites that will actually be consuming this equipment. That supply chain optimization, the logistics cost optimization around that, we believe are part of the solution to further reducing the cost of solar. So if you're not familiar with traditional methods of solar constructions, this is some of the risks and challenges that are facing constructors and owners today. There's continuous challenge on schedule, slippage, and recovery. There are stretched resources. We talked about it this morning. There's not enough people to go around to build these projects. There's a shortage in project engineers. Information is very separated and siloed, analog. People are using spreadsheets, paper, whiteboards. Inventory management is challenged. There's a lot of difficult land situation. Even if it appears that deserts are flat, it actually is difficult to control civil engineering costs. And then there's, of course, quality concerns during construction. So some of our solutions some of our tools that we've built bring digital solutions for this. So at the development stage, we have GIS-based tools that can help quickly design sites, do desktop analysis, assess terrain, and then predict the amount of energy that comes out of site, do cost estimation, LCOE, and quickly enable optimization and site identification or site assessment. On the construction side, we are using drone technology, we're using image processing to speed up the way construction is being monitored or progressed. So we fly drones on a daily basis on the site. enables the ability to capture information quickly, and then we issue reports to owners, to constructors, and quickly recover any risks that may have been emanating from the construction site. We also do logistics as well between the factory of PV manufacturing and then the site. So the way you control that flow between modules coming out of factory and arriving to a site and how long modules are sitting on the field is actually an important consideration for cost. So we help optimize a lot of that. So these are just examples of how digital solutions can be applied to construction to be able to further reduce the cost. More importantly, we're deploying construction automation. We think this is our biggest innovation, and we think there's a huge space here. We're not the only ones pursuing this space. Actually, you'll see a few US companies and a few European companies deploying various approaches to construction automation. What it is essentially a field factory that provides a sheltered environment for workers. They are not exposed to heat. They're not lifting heavy equipment. There's robots that are lifting heavy equipment, and they can actually be provided with further misters for reducing heat. And then there's automated steps for construction automation, for assembly of PV modules on racking, and then we have automated vehicles that install this, and a software that manages all that. It increases the productivity of existing crews by a factor of 2. And then it enables faster construction. So when a site is being built at a faster speed, there's less construction interest that's being incurred, which means you can actually save as a developer on that front as well and build faster on your sites. So that's quite a bit of innovation that we're happy to pursue. We've deployed that in 2 sites in the United States, and we look forward to deploying it in this region of the world as well. We're losing the contact. There we go. Let's see if I'm guessing. Is anybody able to advance the slides? Okay, here we go. So some of the benefits, as I discussed, faster construction 24/7. So this provides a sheltered environment under robots. So you can actually build over 3 shifts, 2x factor, increasing productivity, reduces EPC costs, which improves LCOE, obviously, improves safety, improved quality. And also, this is important, it also opens up the space for PV module manufacturers to build different types of module. Today, believe it or not, module formats are limited by 2 main things. How heavy a module is so that people can carry it on site, and then how well can it fit in a shipping container going from mostly China to the other parts of the world. So if you co-localize the factory and then you remove the need for handling by humans, then you can actually increase the module size by a factor of 2 or even more, which further reduces the cost of the module itself. So this is another important space that will be explored by some of the manufacturer partners that we're working with. And then finally, here we go, hybridization. So we've developed a set of tools that enables us to find the right answer for site or per project for what is the optimal LCOX. Whether you're optimizing for low cost of electricity or hydrogen or ammonia, it's important to be equipped with the right set of tools to be able to get to the answer. As Hadiza mentioned earlier, every site has a different answer with respect to how it needs to be optimized. So equipping with the right tools is the right approach to get to a highly or reduced cost of hydrogen. This is just an example of some of the outputs that our modeling software is doing, and we'll share a little bit more on that. But essentially, you can play around with including batteries or not, and then get some examples of higher or lower utilization rates of your electrolyzers, which tend to be the more expensive part of the green hydrogen. And then finally, co-localization. If we truly believe that once you bring automation on site and you bring digital solutions, you can enable this type of approach for co-localization, where if you have multiple gigawatt scale projects happening around a green hydrogen hub, you could start to co-locate a PV factory, which typically outputs 1, 2, 3, 4 gigawatts per year. And then you can co-locate with that a co-optimized tracker solution as well. The hub gets big enough, you can start to bring float lines for making glass, steel, and then on, and you can start to co-locate a whole industry around that. But it all starts with scale, and then a lot of it is enabled by automation and digitization. And I believe that is it. Thank you.
Thank you, Mr. Amin, for this very interesting and rich presentation. For question of time, we will move directly to the next presentation regarding raw materials impact on hydrogen production. That will be presented by Mr. Massimiliano Servo, who is actually working as a senior consultant, green hydrogen ECMI in Advisem.
Massimiliano, you can share your webcam. Carlo, I'll ask you please to cut off your webcam.
There we are. Yes.
Go ahead, please.
So let me just open this so I can see the dashboard. Okay. Well, good afternoon. I am Massimiliano Cervo, Senior Consultant at Vision, part of Worley Group. I want to thank you all for the opportunity to allow me to be part of the panel. And I want to begin saying thank you to RSN for inviting me, and also to the great panel that we have here with us today. Let me begin. So to briefly introduce Advision, we are a global management and technical consulting firm. We're active across the energy, chemicals, and mining sector. And all of the information that we're going to use for this presentation today is part of our market perspective report. You might know Advision as part of Worley Group, which recently joined part with GISA in Morocco. Let's begin about the metals in the energy transition, which is basically where I wanted to focus. It is important to understand that the energy transition is driving a massive growth in the mining industry, specifically in the lithium, nickel, and cobalt demand for batteries, as well as copper, titanium, and platinum for other technologies. However, something that we can see here today is that there are some materials that are a risk. Supply is not able to keep pace with the demand and projections in some key metals, such as is the case of lithium, nickel, and titanium. For nickel, the cumulative demand is estimated at over 25 million tons through 2050, outstriking known reserves. So the reserves that we have today are not able to fulfill with the forecast demand. There are resources available, but the mining industry is not quite there yet to be able to provide the amount necessary for the next decade. Similar gaps exist for graphite and lithium, so supply deficits could cause price increases in order to control the demand. One of the options is to focus on recycling and substitute of materials and new production, which could help us close the gap in the supply and demand that we can see here for 2030. However, long lead times in new mining projects will mean that supply may be lagging for the next decade. Having said this, more exploration of reserves will be required, and these materials or risks will need to expand their reserves in order to avoid possible congestions in electrolyzer supplies and battery supplies in the next decade. Specifically looking at metals for the electrolyzers, this will most probably affect the capital expenditures. When we look at the metals, alkaline electrolyzers rely heavily on nickel, carbon steel, and aluminum, while in the PEM electrolyzers, they normally use platinum group metals such as iridium, platinum, and titanium. Nickel and platinum are the ones that face the largest supply deficit versus the projected demand. And these tight supplies could constrain the electrolyzer manufacturing growth in the next 5 to 7 years, which would lead to a substantial increase in capex if scarcity drives prices higher due to supply and demand, the basic laws of supply and demand. This can be seen in the peak prices in 2022 and 2021, respectively, for iridium and nickel, which generated an increase in the capex of the electrolyzers during the period of the pandemic. So we need to understand and we need to be very aware that it's not all about resources or natural resources such as solar or wind. We need to also be concerned about the raw materials and the raw resources that are involved in the manufacturing of all of our infrastructure for the energy transition services and energy transition products. Most probably, this will be solved with, as I said earlier, with recycling. And also, we believe that they will be solved with some price adjustments, which will most probably impact in the capex of the electrolyzers. Finally, I want to draw some conclusions based on the levelized costs of hydrogen. Our analysis shows that the electricity prices, capacity factor, and capital expenditures are the main cost drivers of the levelized costs. And with tight metal supplies potentially increasing capex, this would impact directly the levelized cost of hydrogen by 2030, 2035. When we take a look at the global average, this is something that we did from our internal modeling services and market perspective report, where we can actually draw a levelized cost of hydrogen globally for gray, blue, and green. When it comes to green, we're going to see some very wide ranges going from $3.84 to $7 per kilogram. Our projection of Morocco with long-term prices to 2030, we can project a levelized cost of green hydrogen around $4.20 per kilogram. And we must consider that our analysis for the MENA region would require desalination for future developments. And this will also impact in the water requirements, water supply costs that would have a significant impact in the levelized cost of hydrogen. When we take a look at the LCOH sensitivities, at low capacity factors, we see that the country risk premiums and the discount rates tend to have a higher impact than when we move to higher load factors. However, the main drivers of levelized cost of hydrogen at high load factors are the power prices and the capex. So considering this, we would need to find ways to lower the capital expenditures and also lower our power pricing agreements or power purchase agreements. In conclusion, something that I want to say is that while more mining is crucial, prices and technology may help manage the demand growth, specifically in the metal industry. The diversification of raw material sources is key and is going to be very important in order to reduce supply chain bottlenecks. And with careful planning and strategic partnerships, the risks of metal constraints on electrolyzer projects could be mitigated, at least in the short term. Thank you for your time. I didn't want to spend much more. I know that it must be very hard to engage with someone from a computer when you're standing there personally. So thank you so much for your time, and I'm open for any questions.
Thank you. Thank you, Massimiliano, for this important subject. Now I will give the floor for the last presentation to Mr. Carlo Cecchetti. Presentation regarding key measures to unlock green hydrogen potential in Morocco. Carlo Cecchetti is currently seconded by Enel Group to Rest for Africa, and he is managing communications, innovation, digitalization, and circular economy activities. Carlo, go ahead.
Hi, good afternoon, everyone. Let me first of all introduce Rest for Africa Foundation. What is the foundation? It was born 11 years ago by an initiative of the private sector, of European private sector, interested and believing that the future of renewable energies in Africa is really near. So they speed up with the Rest for Africa Foundation, and Rest for Africa function as a bridge between Europe and Africa in the development of renewable energy solution. I would summarize the activity of Rest for Africa in 4 different lines. First of all, the advocate part, in which we mainly discuss with the government, with the institutional relations, about which future could have renewable energy solution in the African continent. Then every year we select 2 or 3 topics of interest in the field of renewable energies, and we analyze this topic. Then we have the training and capacity building activities, where Rest for Africa is one of the most renewable association and foundation in every aspect, so from the economical part to technical part of renewable energy solution. And then we have the technical support activities for the private sector interested in investing in Africa in renewable energies for Africans. In the field of the studies, in 2023, we decided, together with our member PricewaterhouseCoopers, to make a study about the green hydrogen in Morocco, because we strongly believe that Morocco is not leading only in the African continent or in the Mediterranean part the green hydrogen renewable energy solution revolution, but could be also one of the main actors in this worldwide development. So the approach. Let me say that this study, like all our study, can be downloaded for free from our website. So feel free to have a look at the complete study, contact us in case of any question and regarding any possibility of assess other things about green hydrogen. The approach of Rest for Africa for the study was the following: that first of all, we assess the high level of the Moroccan energy sector, and which can be the potential of hydrogen in the light of the existing studies. Second of all, we tried to identify the Morocco's strengths and main barriers in terms of supply, demand, and infrastructure. Then we made an international benchmark to draw conclusion and lessons learned also from other countries. And last but not least, obviously, we made a kind of key recommendation for the development of green hydrogen Moroccan market, in order, first of all, to overcome the barriers of the development of green hydrogen, and to which levers we can activate in order to make this green hydrogen sector to have much more market potential. I will just show you a slide with the summary of the key measures that Rest for Africa identified. We can divide in three parts. The first one is the strategic positioning, where I would like to underline that, how to say, it's important to carefully evaluate the possible target and priorities regarding local consumption and export in Morocco of green hydrogen, and also to study and analyze the option of which of the necessary technology we have in Morocco to develop quicker, which we have, which we don't have, which we can export from other best practice. Then the 5 point is between strategic position and implementation and support. I would underline that it's important the design and implementation of a dedicated, integrated, and coherent policy and regulatory framework. That's why, in such a way, we could enable even much more the creation of bankable contracts for off-takers and for the de-risking investment. Connected with the point 5, I would understand and underline also the point 6, with which will be important to design a clear and a transparent financial support mechanism in order to make a market uptake to close the price gap between green hydrogen and the substitute, as Massimiliano, for instance, was showing us in the previous presentation. Then another issue that I would like to underline, and that also Taka Marocco underlined, was the setup of certification or guarantees of origins is another issue that has to be quickly analyzed, developed, and we have to understand how we can make it, we can call hydrogen really green. Not forgetting that, especially if we have to combine with desalinization and so on, we have to set up technical norms with focus on safety. Also, I would underline for transport and storage of green hydrogen. Regarding the point 9 and point 10, I would like to underline the necessity, but also that there is a lot of possibility to deploy and empower research and development platforms together with think tanks, national companies, and ministries in order to promote the continuous creation of research programs. For instance, together, Rest for Africa, together with IRESEN, we are preparing a couple of call for tenders with green hydrogen subject with the Horizon European Union program in order to have funding for research and development in the field of electrolyzer, but not only, because the target for sure should be to reduce the cost of the technology of green hydrogen. As Rest for Africa, we strongly believe that Morocco has really the potential to do it in a short, medium term. That's all from my side. I thank you once again, IRESEN, and all the organization for inviting me in this very interesting debate.
So thank you very much, Carlo. I want to thank all the experts regarding their valuable information and presentation. And so the panel is closed as we overpass the time allowed. Thank you very much.